x squared minus 3x plus 2. Okay, so this is a parabola, and if you know anything about parabolas, you will know that parabolas are not injective. Okay, so if we have this value of y, you have two different values of x that will give you the same value. Okay, so this is all kind of obvious if you know what parabolas are, but how to prove this kind of more rigorously. First, we do the same thing as before. So we want to solve this equation for x. So how do we solve this equation? Well, we know that this is a second order equation, right? We know that. So we know how to solve these things. This is 3 plus minus, and then this is 9 minus 4 times 2 minus y, okay, squared, and over 2. So if we expand this, this is 3 plus minus, and then this is 1 minus 4 times y. Okay. Okay, so this expression doesn't make any sense if this is smaller than 0. So 1 minus 4y has to be greater or equal than 0, which implies that y has to be greater or equal than minus 1 over 4. Okay, so this already tells you that the function is not surjective. Okay, so again, so parabolas have a minimum in this case. Okay, so this is a normal parabola, positive parabola. They have a minimum. So if you choose a value, I don't know, minus 1000 something, this thing will be negative, and then you can't find an x that maps to this value of y, right? So the range of the parabola is not the real line, it's just an interval from, in this case, minus 1/4 to infinity. Okay, so not surjective. But it's also not injective, because even in the range of the function, if you know, if y is positive, for instance, you will have two different values of x. So for instance, if y is 0, so y equals to 0, you have x is equal to 3 plus minus 1 over 2, which means that there are two values. So it's 2 and 1. Both of them map to 0. Okay, so these are actually the points where the parabola cuts the x-axis. Okay, so not injective. And so you know, in B, so the question in B says, prove that this function f of x is x squared minus 3x plus 2 is injective in 3/2 infinity. Okay, so let's see, how do we say this? I'm going to erase this. So this is not injective in general, given any value of y, but we know that now that the parabola goes, this is 1 and this is 2, and the parabola is something like this, and it does something like this. So this is 3/2. Okay, this is the minimum of the parabola, and this is, we know, minus 1 over 4, sorry. So what the question is saying is, we have to prove that if we choose from 3/2 onwards, okay, so from x, from 3/2 on to infinity, that the function will be injective. Okay, so the easy way to see this is from this solution. Okay, so x, given a value of y, okay, we have two solutions. Okay, we've seen this. Okay, but so it's obvious that because this is going to be either 0 or positive, and this will be either 0 or positive, that this function, sorry, this is always going to be smaller or equal than 3/2, and this is always going to be smaller or equal than 3/2. So if we restrict ourselves to 3/2, this solution to the equation we're not going to consider, because this is not the domain of the function anymore. The domain is only those values of x that are greater. Okay, so the only solution that we care now is this. So now this function has an inverse, which is this one. Okay. Now this is the unique solution. So this will be injective in this domain, 3/2 infinity, right? Okay. Okay, so now let's go for 6. So in 6 we have f of x is x over x squared plus 1. And so we do the same thing to try and see if this function is, let's see, injective or not. Okay. Now this, is this correct? Yeah. So in this case we have if you write the solution for this, we know how to write this. This is 1 minus 1 minus 4y squared, and then you have 2y, okay, because it's 2 times the coefficient of the higher order term. But then you realize this is 2 times y. What happens if y is 0? Okay, so if y is 0, then you have x equals 0. So okay, if y is 0, then x has to be 0. Okay, there's the only solution. This is 0, x has to be 0. This is the only value that maps to y equals 0. Now if y is different than 0, then this expression is valid. Okay, and again we have like in the previous part, we have that this thing has to be greater or equal than 0, which implies that y squared is smaller or equal than 1/4, or in other words, y has to be between minus 1/2 and 1/2. Okay. So again, this function will not be surjective. Sorry. Because if you choose values of y that are greater than this, greater than 1/2 or smaller than minus 1/2, then you cannot find an x such that it's mapped to y. Okay. But it's also not injective, because this function, given 1y, you can find 2x, okay, because you have the plus and the minus variant. Okay, not injective. Okay, now in C they say prove that this function x over x squared plus 1 is injective in this domain 1 infinity, and then find this inverse. Okay, so let's go and work through this. So in the previous parts, what we did is to kind of argue from this expression that there couldn't be 2 values of x. Sorry, that the function would be injective in that domain because it was obvious from this expression. But in this case, it's not obvious. Okay, you can't really argument like that. So we're going to have to go to the definition of injectivity. Okay, so now we're going to choose, so we have injective in 1 to infinity, so we're going to choose 2 values of x, x1 and x2, so x2 is greater than x1, and both of them are greater than 1, and we have to show that these values are different than, they can't be equal, okay, under no circumstances. So let's subtract them. This is the other way to show that a function is not injective or injective, is to subtract 2 values, the values of the function from 2 different values of x, and then see if you can find an equivalence or not. Okay, so in this case we have x1 over x squared minus x2 over x2 squared plus 1 equal, and then so you bring everything to the same fraction. expand, and what we have is x1 x2 squared plus x1 minus x1 x2 squared minus x2 x1 squared plus 1 x2 squared plus 1. Okay, so now what we have x1 minus x2, okay, and we know this is negative because x1 is smaller than x2, and then this part here we can get the common factors, so x1 x2, and then we have x2 minus x1, which is positive. Okay, but if we again take the common factors of these two guys, and then we have 1 minus x1 x2. Okay, okay, so now, sorry, the denominator is going to be positive always, because this is positive plus 1, positive plus 1, positive, positive. But you know, x1 minus x2 is negative, and 1 minus x1 times x2 is also negative, because x1 and x2 are greater than 1. Okay, so this is going to be negative, this is going to be negative. This thing will always be greater than 0. It can't be equal to 0. Okay, so that means that this function is decreasing. Okay, if the function, the value of x1, f of x1 is going to be greater than f of x2, doesn't matter which values you have, as long as this condition is met. Okay, so that means that this function is really injective in this domain 1 infinity. Okay, so actually whenever I'm gonna erase this, when later in the course you're gonna be able to analyze this function and see what kind of function this is. So what you can really find that this function is, well, first of all, it's easy to see that this function is odd. Okay, and so this function has, as we saw, for y equals 0, the resolution is 0. It has a maximum at 1, and it goes all the way to infinity to 0, and then because it is odd, then it's kind of symmetric through the, so this is 1, this is minus 1, and then this is 1/2 and minus 1/2. Okay, so what we're seeing now with the and you will be able to plot this from the tools that we develop. Okay, and so it means that from 1 to infinity this function is injective. Okay, that's what the question is asking. Okay, so now every value of y that we choose will always only have one x that maps to it. Okay, but now the domain will be restricted to 0 to 1/2, you see here. Okay, and now the next question is to find the inverse of this. Okay, so let me copy again the equation for the inverse that we had found. Let me see. Sorry, this was 1 plus minus square root of 1 minus 4y squared over 2y. Okay, so as I told you, this is actually the value, the inverse. Okay, so if we write it like this, changing the numbers, sorry, the letters, the inverse is like this. Okay, well, in this case it's two different functions. So if we plug in here, square root of 2 over 3, then we have 1 plus minus, and then 1 plus, and then we have 4 times, and then 2 over 9, and then we have 2 times the square root of 2 over 3. So this is 1 plus minus, and then this is 1 minus 8/9, so this is equal to 1/9. The square root of that is 1/3 actually, and then you have 2 over square root of 2 over 3. You multiply by 3, both numerator and denominator you have 3 plus minus 1 over 2 square root of 2. So you have two possible values, 4 over the 2 square root of 2, and then you have 2 over square root of 2, which is the square root of 2, and then you have 2 over 2 square root of 2, which is 1 over the square root of 2. Okay. So now so we know that this one of this is around here. This is 1 over the square root of 2, and this is the square root of 2. Okay, so let's call this x1, and then this is x2. So this is x1 and x2. Okay, so if the domain was not restricted to this 1 to infinity, then we will see that the two functions, well, if I had painted this correctly, the two values x1 and x2 actually map to the same value, square root of 2 over 3. But since we're only caring about those values of x that are greater than 1, in this case, the only solution for this, valid solution in this case, for this question is that the inverse of this value in this domain is square root of 2. Okay, so this value is not valid because it's not contained in the domain. Okay, I hope that was clear. And finally, so parts 7 and 8 are easy. So if f of x is e to the minus x, then so we'll write this. Take the logarithm in both sides. So the logarithm of this would have minus x. Okay, and so in other words, you have x is equal to minus the logarithm of y, or if you want, x is the logarithm of 1 over y. Okay. So this function is injective because it doesn't matter. It matters. So first, that y has to be positive, okay, because otherwise the logarithm doesn't make sense. So the function is not surjective. Okay. We know the exponential only has the positive numbers as its range. Okay, so the function is not surjective, but it is injective because given one value of y, such as it is positive, then you can only have one value of x, okay, because the logarithm is also an injective function. Okay. Finally, the f of x is the logarithm of x plus 1. So y is, and so we exponentiate both parts, so e to the y, and then this is e to the logarithm, so we have x plus 1, and then we subtract 1, and this is the result. Okay, so again, this is injective because it doesn't matter which value of y you choose. You can only so if for different values of y you will have different x, and it's also surjective because the domain of the exponential is the real line, so you can plug in any real number here and you will have an x. Okay, so this function is bijective. Okay, and so yeah, that's it. We have also solved parts B to D, so that's the end of the problem.